Good afternoon, ladies and gentlemen. Welcome back. This is lesson 3. My name is Mr. Chen for MCR3U, grade 11 functions. I do want to apologize if there's a high-pitched sound. For some reason, I can't get rid of it. But let's get to it. Lesson 3, I'm going to probably break this up into 2 videos. And the first video is actually going to talk about given a graph, determine its equation. So that's what we're going to be focusing on today, or for the first video. The very first page is informative, and it talks about the relationship of the unit circle and that sine graph. So consider a point moving along around a circle. Amplitude is related to the radius of the circle. So first of all, let's draw the unit circle really quickly. And as you can see, I'm just tracing it. That radius r represents that amplitude. So that's radius. Same thing with this one. Notice the amplitude changes. Notice that amplitude there, that radius. So that radius is really neat connector. The radius is the same thing as amplitude. Keep in mind, we're only dealing with sinusoidal functions. The period is related to how fast the point moves around the circle. So let's just exaggerate it. Notice, if I were to trace around the unit circle this time, let's just say it took me the time 1 minute. I'm exaggerating. That means that period is going to be 1 minute. Right? How about this? Maybe it takes me a little bit faster than 1 minute. And the time is actually 30 seconds. So that's going to be 0 to 30 seconds. And finally, everybody see if I go really, really fast, and the time of, let's say, 10 seconds, that period is going to be only 10 seconds. So it's just how fast or how slow a point moves around that unit circle. The last part of this chart that's unfortunately not animated. Phase is actually related to the initial position of the point on the graph. And what you're supposed to be looking, first of all, if we go counterclockwise of the unit circle, counterclockwise. If we were to take snapshots of that point on there, you can see its position on the y equals x graph, or y equals sine x graph, is a little different. That dash mark is really the reference of the sine graph. So as you progress from left to right, in the sequence, like 1, 2, 3, all the way, you're seeing as we keep on rotating, and I wish I could animate this, I cannot, but you're seeing that slowly as the vertical axis moves across from left to right, that position changes, right? So you're kind of seeing that rotation of that unit circle. So if you remember what I just said at the beginning of this video, I'm actually going to teach you, first of all, how to interpret a graph. Given a graph, can you actually find its equation? So I'm actually skipping activity 1 and activity 2. We're just jumping to activity 3, which I think is on page 5 of the handout. There's a couple things we have to do, first of all, and read the question. On this page, activity 3, each of the following graphs was obtained from the graph of y equals sine x. As a recap, the sine graph looks something like this. I'm just doing a quick sketch. Starts at 0 degrees, 2 pi, we're going to be using radians, has a maximum of 1, and has a minimum of -1. And there are 5 critical points. And I'm basically looking at an analysis of the graphs that are provided for us. So we have to do a couple things. What is the defining equation of each graph? That's actually hard to do. For each function, state also the amplitude, vertical displacement. This is also known as the equation of the axis. The period and the phase shift. So A, P, D, and S. Again, most students, we're actually going to do the very first question together. Most students actually can give me these 3 critical points, or these three critical information right away, just by looking at the graph. And hopefully, I'll kind of go through it slowly so that you can follow along. We'll try to do 3 of these. So for question A, what's the amplitude? Well, the amplitude, if you look at the very first graph, we can do a couple of ways. We can look at the maximum, look at the minimum, and use that equation that we actually learned already. However, most of my students would actually look at that portion. That's the amplitude. And that amplitude has to be 1. Now, I understand some of us, when we're looking at this, why are we doing this information? It's like an intermediate step to find that equation that we're going to write as this formula. This is the form that we're going to be using. And we'll come back to this over and over again. But we can't just jump to this right away. How about the equation of the axis? We'll use orange, I think. The equation of the axis, again, we can use the maximum, the 1, the minimum, -1, and also find that equation of the axis. But a lot of you realize that equation of the axis is going to be 0. So that's 0. Finally, not finally, the second last of the 3 blue things that I've circled, the phase shift, that's S. The phase shift, well, this is also a little tricky. What's the phase shift? Well, since it starts at 0, 0 for y equals sine x, and this graph also starts at 0, 0, chances are there's no phase shift. So some students say, why are we doing this silly example? Well, the only one we have to really worry about when we use pink is what's the length of the period. And again, just to go slowly, most students will actually start there and go all the way to there. The reason why is because that's what a lot of students look at for this period. This period is actually 2 pi. This period is actually only 1 pi. Notice it did not matter if we actually chose these 2 maximums, right? That length should still be pi units, right? So we have a 1, we have a 0, we have a pi, and we have a 0. And how are you actually going to write into this equation? Well, let me give you the answer first of all. And explain it in an uglier way on the underneath, why we got this. Let's go back a little steps. I need the rough paper, so here we go. You learned already from the transformation unit this generic form of the function notation, where A is the vertical stretch or compression, the B value is the horizontal stretch. I spelled that wrong. Or compression. The C value is the horizontal shift or translation, left and right. And the D value is the vertical shift, up and down, of any function. So we already learned this. And yet, down below, we're going to try to rewrite it this way. So I think some of you actually know the ugly way of doing this. And this one, unfortunately, this first example, question A, might seem weird, but let's just write it out. So y equals 1. Amplitude is related to the vertical stretch. We're going to leave the b value alone because I told you that was the hardest part. So let's do x, and there doesn't seem to be any phase shift, but let's just do it anyways. I think I used orange. So x minus 0, and purple, plus 0. So that's my A. I haven't written anything for B yet. That's my C, and that's my D. So what is the P or the B value? They are related, but notice, unfortunately, we can't just plug in the P and the B. That's why I'm trying to show you, ladies and gentlemen, the A, D, and S seem to be the easiest ones. So there is a relationship between the B value and the period. If we were working in degrees, you take 360 degrees and you always divide it by the period. But since we're not dealing with degrees, we're dealing with radians, we'll do 2 pi over P. So in this example, the B value is going to be 2 pi divided by pi. Pi divides that pi, and that's why we get 2. And that is why this is the answer. Let's try another one. Let's try question C. And again, I'll help you. I'm going to help you with all the information that you have to do. Again, you might think of other things and other strategies. And the only one that most students will find a little different is probably the phase shift and the period. But the amplitude and the equation axis, I think everyone's going to be all right. Watch what I'm going to do. Amplitude is probably, well, 1. Equation of that axis, still 0. That's why I put 0 there, y equals 0. Phase shift, well, sine graph, notice, it's starting at 0, but it's descending. So most students, and there's actually a couple of answers here that we can use. Actually, there's an infinite number of answers, but for most students, the phase shift, and I think I was using purple, the phase shift that some students would say, Mr. Chen, you started right over there. So left pi units. So this is the analysis that we're looking at for the graph. So what's the period? Well, the period seems to be, if we go from there to there, and again, we could have taken the minimum to minimum or maximum to maximum. I think everyone agrees the period is going to be 2 pi. Doing some math, really straightforward. What's the equation? Now for this analysis that I've done, I think everyone's okay. Just to do some math here for this b value, 2 pi divided by 2 pi. Well, that's actually 1. So what is the answer? Y equals sine. Notice there is a 1 there. We could put it in, but that's silly. And there is also another one that's also a little silly. Left, what's left? Well, that's going to be x plus pi plus 0. This is ugly, but most students will just write like this. Y equals sine x plus pi. There is another answer, though, right over there. Y equals sine x minus pi. There's actually a third answer, but I'm going to let you try to figure that out on your own. The last one we're going to do for this part of the video is question F. And again, there are answers, right, in this package. So I'm just trying to help you through it. So this time, most students, again, if you haven't been figuring it out, I tend to have a particular way of solving things, and it tends to be the good tip. Now for this question F, there's no grid lines, and this one seems harder, and it is harder. But this one I think actually is a little neater. A lot of you already noticed that I chose the orange color. It's because I am probably actually going to first find the equation of that axis. And that happens to be y equals -1. That's the first one that I tend to do. The second one is really easy, the amplitude. And a lot of you can see that part from there to the equation of the axis there. That's probably 2 units. Phase shift. Again, my eye is looking actually right about here, because I tend to read from left to right. So that's my phase shift that I'm going to say. So I'm going to say it starts left again, pi over 3. There is another answer, but you could definitely use the positive pi over 3, but I don't want to confuse you. The only hard part now is to figure out this period, and a lot of students have trouble with this. But I think you guys actually understand. I'm going to trace it out again in pink. If I take that cycle, that one cycle, even though there's so many cycles to choose from, and I could choose the maximum to maximum or minimum to minimum, this one's probably the easiest for us because it does look like the sine graph or sine portion. That length from here to here is what we need to figure out. But that distance from there to there is a third pi, and that is also a third pi. It just happens to be nice and even. So adding those together, 1/3 pi plus 1/3 pi is 2/3 pi. So there you have it, ladies and gentlemen. We have all the information. Most students will actually understand, and I'll do this hopefully in colors that you can see. The amplitude is the same thing as the A value there. The D value is the same thing as the D value there. Notice the A and D seem to be easy. The phase shift, a lot of you actually understand this. X plus pi over 3, which really means left pi over 3. The only hard part, again, one more time, is to find out that B value. And that B value is related to 2 pi divided by its period. In this case, the period was 2 over 3 pi. Some of you are a little rusty with your fractions. The B value, and I'll just do it over here, I apologize, I'm running out of room. The B value is equal to 2 pi multiplied by the reciprocal. And we should put that pi down below if you want. And that's actually where it was. So let's just erase that. Because that's what we're doing. Those pi's divide out, that 2's divide out, and then we're left with 3. So there you have it, ladies and gentlemen. To keep on going, activity 4, and just to give you my advice, y equals cosine x. The cosine graph looks like this. Same kind of properties, from 0 to 2 pi. The maximum is 1, the minimum is -1. Except it starts at a maximum. Okay, so let's see if you can do that yourself.